Hi and welcome to a tutorial over chemical reactions. Please have out your notes as well as your white practice packet. A chemical reaction is the rearrangement of atoms to form new substances. Reactants always appear on the left and products are always on the right. In our example here, we have something called the synthesis of water. We've got hydrogen gas reacting with oxygen gas to produce water. There are 5 signs of a chemical reaction. So if in class we have you do a chemical reaction, we need you to be aware of what those signs are. So 1 is that a gas can be produced. 2 is that a light might be produced. 3, a precipitate is formed. Please highlight that word precipitate. It's when you mix together 2 liquids and a solid is formed, like the picture below. A temperature change, exothermic or endothermic, and a permanent color change as well. Balancing equations. According to the law of conservation of mass, matter is not created or destroyed in a chemical reaction. So the mass of all the reactants must be equal to the mass of all of the products. So here's an example. It reads, what is the total mass of reactants in the reaction below? Okay, well, we know that this arrow really means equals. So products need to equal reactants and vice versa. So if I know that the product is 72 grams, then the reactants must also equal 72 grams total. Example 2. What is the total mass of products in the reaction below? Well, we have the mass of the silver nitrate and the sodium chloride, which are my reactants. Again, if reactants are supposed to equal products, I can just add together my 2 reactants and get the total mass of the product, which is 226 grams. And that's total, of course. And example 3. Go ahead and try this one on your own. Okay, welcome back. Hopefully you were able to do example 3 on your own. In order to figure out the amount of zinc produced, we set this up like an algebra problem. So it would really be 40 plus 125 equals 100 plus x. We're just solving for x. Okay, so I'm going to go ahead and simplify. 40 plus 125 is 165, which equals 100 plus x. If I subtract 100 from each side, then zinc must be 65 grams. Okay, pretty easy. Okay, and again, this should be a review, so you should be pretty good with law of conservation of mass. Because the law of conservation of mass always holds in chemical reactions, we must always be sure we are working with a balanced equation. A balanced equation is one in which the number of atoms of each element is the same on both sides of the arrow. Very important. Okay. So again, that arrow is really an equal sign. All right. So here's an example of an equation that's not balanced. Okay. So we are going to count the atoms on each side. Sometimes I draw a line here just to indicate left versus right. So we're going to count atoms. Okay, so on the left side, I just have 1 sodium. I've got 1 iron, and I've got 3 chlorines. I know I have 3 chlorines. It's indicated by that subscript, which only applies to the chlorine. On the product side, I have 1 sodium, 1 chlorine, and 1 iron. This is not balanced because the chlorines are not equal. Okay? If we look at the next example, it is balanced. So again, I'm going to do an atom inventory, which is just adding up how many atoms of each element I have. So I've got 3 sodiums on the left side. I've got 1 iron and 3 chlorines. Okay? Again, coefficients and subscripts are what tell me how many atoms I have. Okay? On the product side, I have 3 sodiums and 3 chlorines. Remember that a coefficient is going to apply to both elements or all elements in the compound. So 3 sodiums, 3 chlorines, and just 1 iron. So because they are the same on both sides, this is a very good thing. We have a balanced chemical reaction. The big numbers that are used to balance the equation are called coefficients, which I have in red here. Subscripts are the small numbers written in formulas. They stand for the number of atoms or polyatomic ions immediately to their left. So for iron 3 chloride, this little 3 applies to the chlorine only. So I've got 3 chlorine atoms and 1 iron atom here. So what it would look like is an iron surrounded by 3 chlorines. Okay, and we'll learn to draw these later, but this is just a general idea of what that looks like. With magnesium nitrate, this 3 is a subscript for oxygen. It applies to the oxygen only, but the 2 is going to apply to whatever is in the parentheses. Okay, so it applies to the nitrogen and to the oxygen. So for example, what this would look like is a magnesium with a nitrate on each side. Okay, that little 2 stands for the 2 nitrates we're seeing right there. Okay. When balancing equations, only add coefficients to balance. Never alter a chemical formula in the equation in order to balance. Okay, so for example, I cannot add a subscript like this. That is bad. You cannot alter that. It's not the same chemical if you do that, or compound. You can only add subscripts, which are the big numbers in front. So let's do an atom inventory to see what's going on and what's not balanced in this reaction. Okay, so I've got calcium, I've got oxygen, and carbon. On the left side, I've got 1 calcium, I've got 1 oxygen, and 1 carbon. On the right side, or the product side, I've got 1 calcium, I've got 1 oxygen, but I've got 3 carbons. So 2 plus 1 gives me the 3 carbons. So I can see here that it's carbon that is making this not balanced. Well, simple solution. By adding a coefficient of 3 on the reactant side, all of a sudden, this becomes a 3, and I am now balanced. One important thing to know is that the coefficients for any blanks are going to be 1s. Okay, so I have 1 calcium oxide reacting with 3 carbon atoms, etc. Okay. Let's look at another example. This one's from the white practice packet. It's a little more challenging than the one in the notes. So number 2. Okay. I'm going to go ahead and do the atom inventory. Every teacher kind of has their own little way of showing the atom inventory. I'm just showing one example here. Okay, so on the left side, I've got 1 aluminum, I've got 3 bromines, and 2 chlorines. On the product side, I've got 1 aluminum, 3 chlorines, and 2 bromines. So it's obvious to me right now that it's bromine and chlorine that are not equal. So to do that, we're going to add coefficients. Well, what's typical is that you look at the largest number. For example, bromine, there's 3 on the reactant side. And then I try to make the other number on the product side equal to it. Well, there's no whole number that I can multiply 2 by to make it 3. So in that type of situation, you go for the least common multiple. The least common multiple of 3 and 2 is 6. So I'm going to make 6 bromines on the reactant side and 6 bromines on the product side. Watch how I do this. Okay. So on the reactant side, I'm going to add a 2 here because 2 times 3 gives me 6. On the product side, I'm going to add a 3 because 3 times 2 gives me 6. So now I'm balanced. But, well, for bromines at least. But when you added this 2 as a coefficient to aluminum bromide, it didn't just affect bromine. It affected aluminum as well. So now I've got 2 aluminums on the reactant side. Well, now I have to hop over to the product side and fix this by putting a 2 in front of aluminum chloride. Okay, so that's a good thing for aluminum because aluminums and bromines are now happy, but it didn't just affect aluminum, it affected chlorine as well. So 2 times 3 gives me 6 chlorines on that product side. So I need a 3 here in order to balance out the chlorines. Okay, so I highly recommend using an atom inventory to help you. Good luck in your practice with this. Please see the website if you need additional help. Have a good evening.